operasional pembangkit secara keseluruhan. Sedangkan boiler optimization adalah program yang memaksimalkan boiler sehingga pembakaran juga lebih optimal. Optimasi operasi dan optimasi pembakaran akan mewujudkan efisiensi bahan baku yang lebih baik sehingga dapat menurunkan BPP secara signifikan. Seberapa besar manfaat I-Core? APM dapat mewujudkan zero force outage dan manfaat dari optimasi adalah penurunan NPHR yang mencapai 4%. Selain itu, APM meningkatkan efisiensi kerja, memperpanjang umur peralatan, dan mengurangi biaya ekspertis karena semua telah diprediksi secara terpusat. Boiler optimization mengurangi opasitas emisi, menjadikan pembangkit lebih hijau dan ramah lingkungan. Singkatnya, listrik yang dihasilkan tidak hanya terjamin kualitas, namun juga ketersediaannya didukung dengan harga yang efisien dan yang terpenting, ramah lingkungan. Kehadiran PJB I-Core menjadi pembuktian PJB yang telah siap menyambut industri 4.0 dan berkomitmen menjadi solusi bagi PLN dalam menyediakan listrik yang andal dengan biaya yang efisien. Mari bersama-sama menyambut era baru pembangkit listrik di Indonesia.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, audience and presenters. Welcome back to e-conference PJB Connect 2020. In the previous day, we have seen papers with the topic of renewable energy, industry 4.0, environmental impact, and other energy and power technology. Now, let us continue with the topic of asset management. Before we start, there are rules for this event. Number 1, presenter will share screen and play 10 minutes video presentation that has been made previously. Number 2, audience are not allowed to unmute themselves during the session. Number 3, audience can ask questions in a 10 minutes video presentation and during a 15 minutes Q&A session. Number 4, audience questions are only allowed via live chat Zoom. And last, number 5, question can be asked in Bahasa or English. On this first occasion, we will see a scientific paper with the title Implementing Risk-Based Maintenance Strategies for Distributed Control System as Power Plant Asset Management, which will be presented by Mr. Danantri Yulianto from PT PJB. Hi, Mr. Danan, are you ready to spark your silver horizon? You have 10 minutes.
Hi, hello.
Yes. Are you ready, Mr. Danan?
Yeah. Yes, I'm okay to go.
You have 10 minutes to present your paper and 15 minutes to answer the question from live chat. Please begin your presentation.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thank you for the audience for coming, and also thank you for inviting me to speak on PJB Connect. This session, I would like to present about risk-based maintenance on DCS system. DCS system is a power plant control system and play a role like a human brain. So let us start our presentation. Please enjoy and prepare some questions. Mbak Emmanuel, please play the video. Assalamualaikum warahmatullahi wabarakatuh. It's a pleasure for me to be here at 6th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering. The issue I would like to bring up on this session is about implementing risk-based maintenance strategies for distributed control system as power plant asset management. And let me introduce myself. My name is Danantri Yulianto. Begin with the next slide. First, let us begin with the introduction about Muara Tower Power Plant that consists of 5 blocks. block 1, 2, 3, 4, and 5. Each block controlled by different type of DCS. DCS needed to regulate power plant for electric generating. Let us give a brief introduction about Mora Tower control system. Block 1 have ABB type of DCS. Block 3, 4 with the Siemens, and block 5 also with the ABB. We go next to our next slides about brief more about the DCS system in Mora Tower power plant block 1 and 2. The DCS system in block 1 of Mora Tower power plant with the type of P13 and P14 stand for Pro Control 13 and Pro Control 14, used by gas turbine and steam turbine. Is a ABB manufacturer. This DCS control already operate since 1997 and now is 23 years operate. According to the CART assessment that we did on 2015, that our DCS system CART is 96% is in classic phase and 4% is limited. And based on the number of DCS failure from 2016 to early 2020, this DCS failure contribute to the operating and production. That is a problem also, that the DCS also have a big impact to our production side. Now we're going to the method on. First, we are going to discuss about distributed control system, that we are going to separate into some variable and indicator. The variable consists of DCS system, DCS failure, DCS risk, and maintenance. Each variable has indicator, such as DCS failure. We have indicator from failure report, critical control card according to the cubicle location, and the number of failure within duration time to determine the reliability. Now we are going to about risk-based maintenance. Risk-based maintenance, according to some journal, divide into 4 main steps. One is the fight system in manageable unit, then consider it on 1 unit at a time. After that, we do the risk estimation and risk evaluation. From these two methods, we generate a flow chart. We have to determine, we have to collect the DCS failure record. After that, determine the DCS critical area using the Pareto diagram and the fault tree analysis. After we got this critical area, the main idea is to determine the consequence and the probability of failure. As we know that the risk is combining of consequence of failure and probability of failure. Consequence of failure we determine with four main idea about system performance loss, financial loss, human head loss, and environmental loss. Then the probability of failure, we do the reliability calculation based on the data, based on the failure record that we already collect before. After we collect the data, then we determine it using its distribution of reliability related to their data, whether they are using normal distribution, log normal, Weber distribution, or exponential. After that, after we got the consequence number and probability of failure number, then we can
we can manage risk metric, risk level metric. We are going to the research and discussion. Let us take a look at the whole system of the DCS Block 1 and 2 monatomic power plant that consists of 17 main area of DCS. Gas turbine 11 until to steam turbine 1.4. They are divided into several cubicles, and every cubicle has their own function, whether it's open loop, closed loop, or control the boiler, control the steam turbine, or the protection itself. Okay, let's we go to the next step of determine risk based maintenance. First, we have to determine of the DCS system critically ready. We are using two scheme. First scheme is about failure scheme of DCS. As we saw on the screen, that the DCS system on Block 1 consists of DCS on every set of gas turbine, and the boiler system, water steam cycle, and the steam turbine cycle. Every DCS will contribute on the failure rate. It will contribute on the failure rate of on the higher level of this failure scheme. Next, we collect the failure record to determine the Pareto chart of DCS cubicle. We do the reliability calculation. We will solve the result of the reliability calculation. We give a 5 example of the reliability. For example, from 12 CPA 11, this DCS to control the boiler on unit 12. The data show that the distribution. The data show that the distribution is normal, with mean 513, standard deviation 420, failure rate 0.8. This whole data we are collect to the next step. It is consequent failure and risk. This is the result of the probability of failure within 1 year. That every cubicle have the potential failure within 1 year. Based on the risk index that they are on a high level. There are 14 CPA 02 and 14 CPA 03. These are the DCS to control the steam turbine. What is the main purpose of risk-based maintenance? First, we use those data as a maintenance schedule. As we calculate the reliability on each DCS, we can calculate maintenance interval or the preventive maintenance interval before the system will get a failure or alarm or any other thing. The other purpose of risk-based maintenance is to, as we know that we are going to generate a risk mapping. As we know, as we saw on the screen, that there are two DCS systems that on the high condition to make this area into acceptable condition. Next we are on the last chapter about the conclusion. That there are 4 conclusions that we want to share with you. First, that DCS system ranking risk with high level and became a major concern was cubicle 14 CPA 02 and 14 CPA 03. Number two, that the DCS maintenance interval on cubicle 14 CPA02 and CPA03 effectively scheduled around 29 days. Next, risk mapping and maintenance schedule would help to prevent the loss production from DCS failure. The last, further research need to determine the value of electronic equipment on DCS to get accurate reliability number. Thank you. That is all from us. Thank you very much for your kind attention. Nice to have a discussion. Nice to have this opportunity. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, Mr. Danan, we have a question here in the Zoom group chat. What things affect the calculation of the preventive maintenance interval on DCS equipment? You have 15 minutes to answer the question.
Okay, thank you. From Mr. Budia, what thing affect the calculation of the preventive maintenance interval on DCS equipment? Well, preventive maintenance derived from the reliability calculation. After we calculate the reliability, we can get the number. When a machine or when a system going to the reliability is lower than 0.8, then we have to do some maintenance, whether they are preventive or maybe some corrective maintenance. So actually, the reliability is based on the like historical data, that we collect about the when the failure is happening and why it's happened. From the data, we can calculate into the reliability and then the risk management also. Is that Pak Budi, Mas Budi, is it answer your question?
Okay, I want to remind the participants that the participants can ask a question in the Zoom group chat. And before that, I want to ask Mr. Danan, what is the biggest obstacle doing this research, or the biggest problem in doing this research?
Well, but Emmanuel, this is one month research. It's 1 month research, but I have to collect 3 years data. That's our biggest obstacle to write this condition into the paper that we present today. Actually, how to collect 3 years data, and we must finish it in 1 month. This is our biggest obstacle.
Okay, thank you. Please freely select the questions from our Zoom group chat. Mr. Danan, there is a question from Mr. M. Fikri. Where is your research take place?
Mr. Fikri, this research is, we are doing this research in Pembangkitan Jawa Bali, Muara Tawar Power Plant, Block 1 and 2. But we are trying to expand our research to another block 3, 4, and 5, and maybe some other power plant. Thank you, Mr. Fikri, for your question. From Pak Andri, Mr. Chemical, I want to ask about how to ensure the effectiveness of this simulation result with actual condition. Well, Mas Andri, why we are choose the risk-based maintenance, because it depends on what purpose of our research. We choose risk-based maintenance because we want to know which risk level our system is in, or what kind of reliability that our system has. To ensure the effectiveness, well, it is a good question. To answer this effectiveness, we must to compare the data from the historical failure data, and then we try to calculate it, whether this data are same or not. We calculate this data, and then the effectiveness it shows that the data mostly show the same data. Is that clear, Pak Andri? As long we use historical data, then we can do some comparison between those data. Question from Pak Rahmadi Setiawan from PT POMI. What kind of DCS that you use for your survey? We use DCS EPP P13 and P14. A-control P13 and A-control P14. Gas turbine is P13, steam turbine is P14. From, okay. Again from Pak Rahmadi Setiawan, what kind of data from DCS you use for MTBF? We use the failure date, Pak Rahmat. We collect the failure date that's shown on the that we collect. We record manually, or we record automatically from the DCS system. That the data that we use from. Okay, Pak Andri, thank you, Pak Andri. Pak Fikri, okay. Pak Agus Hamdani, thank you. Mas Previ, I want to know more about your equation. Please, can you explain to me? Well, this equation is about the risk. Risk is a combination between COF, coefficient of failure, consequence of failure, and the probability of failure. The consequence of failure, the equation is quite simple. Only calculate for condition based on the effect on the economical operation, safety, and environment. The more sophisticated one is about how to calculate reliability. We do some calculation manually and use some software like a Rayleigh-Soft wave pool, and we do some graphical calculation. First, we must determine the data distribution, whether it show the log normal distribution or wave pool distribution, maybe some normal distribution. After that, we calculate again. Calculate from the data to as we explain on our presentation, that there are some equation that we use to calculate until we got the number of reliability. Okay, Mr. Previ. Mr. Previ is Moratower, eh? It was Moratower, yeah. From Mr. Alco, what kind of maintenance action that can uphold while plant in operation? Okay, to do some maintenance during operation is quite sophisticated. because we have to avoid the machine to suddenly stop or trip. So we must taking care of it. What we can do during planned operation is simply preventive maintenance, or do some more maintenance into the DCS system that not operate in function. The function is not on the critical point. Critical point means that if we do some maintenance, if we do some taking out and taking in card, it will trip the unit. We must plan to do some safe action. Okay, Mr. Albo. From Mas Gunawan, okay, thank you. From Pak Mahadi, can the data be obtained from GMS history, manual collect? Yes, we collect from the GMS data. We collect from the ellipse, and we do ellipse data that show ellipse data, and also the historian data from the DCS. Pak Shaf, oh, thank you. Pak Brevi, okay, thank you. Okay. From Pak Rahmadi again, from the result of MTBF calculation, what kind of preventive maintenance you put on this case? Yeah, we have a standard preventive maintenance on DCS system. Preventive maintenance on while the machine is not operate and the machine operate. So we have to these two conditions. Some system can be do with preventive maintenance, and we also have other strategy to make sure that our spare part, DCS spare part, is available. So what kind of preventive maintenance? Yeah, we are based on our maintenance standard on the preventive. Okay, Pak Ramadi. From Mr. Saddam Yusuf, what are the difficulties experienced during implementing risk-based maintenance strategy for DCS? Well, the difficulties during implementing this kind of strategy is back to our commitment to do this accurately. We do this always to do this system. I mean, as a human, we have maybe some human error to implementing this condition. As long as we do this effectively, I guess it okay to do. Again from Mas or Pak Ruli Isfi, maybe Pak Ruli Isfi. Can you explain about your conclusion for the research, how to get accurate reliable number? The conclusion that we have collect, and we already determine the risk level on each of our DCS system. We got two main area, two main DCS system that we must be always taking care of it, because it have a critical level and risk level is in high level. For the research, in my mind, for the research that our reliability is only based on the historical data. It will be very good if we combine it into the Itu the real-time data. We can use machine learning to predict more accurate whether the system will be failure or not. That may be the further research. Then how to get accurate reliability number. 3 years of failure data, I think is enough to make this reliability number accurate. There are more than 5 or 6 data each DCS system. Based on the reliability, it is accurate because we collect those data. There's a lot of data we calculate and we collect and we calculate. I think that's the last question from Pak Ruli Isvi. Yeah, Mbak Imaya.
Yes, Mr. Danan. We are really sorry to inform you that the Q&A session is over. Thank you, Mr. Danan, for your scientific paper presentation with the title Implementing Risk-Based Maintenance Strategies for Distributed Control System as Power Plant Asset Management.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, for the upcoming session, we will proceed to the next scientific paper with the title PT PJB UPHT Calibration Laboratory Business Strategy with Business Model Canvas Method, which will be presented by Mr. Irfan Ardiansyah from PT PJB. Mr. Ardiansyah, are you ready? Mr. Irfan, are you ready?
Hello, best regard for everyone. I'm Irfan Ardiansyah. At this moment, I will present.
I'm ready, Miss Emanuela.
You have 10 minutes to present your paper and 15 minutes to answer the question from live chat. Now you can start the presentation.
Assalamualaikum warahmatullahi wabarakatuh. I'm Irfan Ardiansyah. At this moment, I will present our paper that entitled PJB UPHT Calibration Laboratory Business Strategy with Business Model Canvas Method. Please enjoy the presentation. Please, Ms. Emanuel, to share the presentation.
Paper entitled PJB UPHT Calibration Laboratory Business Strategy with Business Model Canvas Method. The introduction. PJB UPHT is developing a calibration laboratory and in the CAN accreditation process. The initial goal of establishing a calibration laboratory was to self-manage the calibration internally. With the enactment of the AEC, the potential for the calibration market in Indonesia is promising. Calibration laboratories can be further developed as a new line of business. For this purpose, the business strategy should be applied to a calibration laboratory based on an appropriate business model. This paper has objective to determine the current calibration laboratory business model, create several alternative business models for calibration laboratories, determine the most appropriate business model for a calibration laboratory. Research method. The study was conducted at the calibration laboratory at PJB UPHT in Gresik, East Java. The study was conducted using qualitative descriptive methods. The data used in this study are primary and secondary data. Primary data were obtained from interview with the head of calibration laboratory and the result of the FGD with 5 people who were calibration laboratory team. Secondary data is data that has been collected by other parties in the form of document, literature, books, and in the internet. Data collection techniques used in this study were carried out through interview and FGD. Business model development is carried out through a series of analyses which begin with a descriptive analysis that analyze the current condition. Identification non-elements of a PMC is needed to determine the goal to be achieved by the organization or according to the objective to be achieved. Furthermore, each element is assessed in detail with a SWOT analysis of internal and external factors. PMC and SWOT is the basis in the designing alternative PMC1. Next, an analysis is carried out using POS with a 4-step framework analysis tool. Of the 9 elements of the current business model canvas will produce alternative PMC 2. From the two alternative PMC minutes, decision analysis will be conducted to obtain the business model that is most suitable. The strategic action plan will be prepared to obtain the calibration laboratory business strategy. Analysis framework can be shown in this picture. This is calibration laboratory current PMC. In the customer segments blocks, there is an internal PJB. In customer relation blocks, conducting outreach in the internal forum of PJB companies, such as through the KSF. In channels block, office automation, phone and WhatsApp, and email. Value proposition block, master calibrator are among the highest in this class for the scope of electricity. The calibration time is faster than the external calibration laboratory. Key activities block, calibration of measuring instrument and instrumentation. Key research block, calibration laboratory room. STM consists of 3 coordinators and 10 calibration engineers from the maintenance sector. Master calibrator, 1 set for each scope. Quality guidelines according to ISO 17025. Key partners block, 1. Master calibrator supplier. 2. Surveyor Indonesia as an accredited consultant. 3. CAN as an accreditation institution. Constructors block, fulfillment of laboratory facilities and infrastructure. 2. Consultant service. 3. Accreditation fee. 4. Laboratory equipment. In the revenue streams, it still don't have income yet. To get the alternative PMC1, a SWOT analysis was carried out to improve the current PMC by FGD. From the SWOT of each canvas building block, identification of internal and external factor will be carried out as shown in Table 1 and Table 2. From the result of the analysis of internal and external factor table calculation in Table 3 and Table 4, it shows that the value of each score, namely the internal factor of strength, has a score of 1.40 and the weakness factor has score of 2.00 with a difference of minus 0.60, while the external factor obtained for the opportunity to have score of 1.78 and for traits have a score of 1.26 with a difference of plus 0.52. From the next identification process, the calculation process score to determine the quadrant position on the SWOT diagram. Position of calibration laboratory in the SWOT diagram can be seen in Figure 3. Based on that, it found the calibration laboratory industry is in Quadrant 3, which supports the turnaround, namely business conditions that are facing enormous opportunities, but also has several internal obstacles or weaknesses that must be faced. Business development obstacle efforts can be done by making improvements to the elements that are weakness in the company. The strategy used in business condition in the turnaround quadrant is to apply the weakness opportunity strategies. Alternative PMC1 was designed from the current PMC, which is being improved based on SWOT analysis that has been done for the 9 elements of the PMC. Improvements were made to 7 of 9 canvas elements as shown in this figure. The blue color shown the improvement has been made. Alternative PMC2 generate using the POS analysis. The POS analysis is carried out using a combination of a 4-step framework and current PMC. The design of alternative business model combined with POS principle raise 4 main questions, namely what can be created, eliminate, improve, and reduce, referring the current and future condition. From the result of the POS analysis, obtain an alternative PMC2 as shown in this figure. The blue color is create, the pink color is eliminate, the Yellow color is improved. There is none to reduce. After obtaining the alternative PMC as explained previously, it is necessary to analyze the decision making to determine the best PMC for the calibration laboratory. Analysis of decision making is done using the Minnow concept. An alternative PMC 1 and 2 will be carried a screening and evaluation process based on absolute criteria and desires that have been determined as shown in Table 6. From the Table 6, we get the data that alternative PMC1 gets a value of 287, while alternative PMC2 gets the value of 379. From the two alternatives, the results show that the alternative PMC2 more meets the requirement of the desired criteria compared to alternative PMC1. From the result of the assessment, it is found the alternative PMC2 has a greater desired criterion value than alternative PMC1, but it is also known that alternative PMC2 has higher adverse consequence than alternative PMC1. This means that alternative PMC2 has more promising business potential than alternative PMC1, but it is require more effort to run it on time and cost. Therefore, with this consideration, a decision was obtained that alternative PMC1 will be applied first and after 2 years will be replaced by alternative PMC2. The conclusion: 1. The development of PJB UPHT calibration laboratory business model is done by using SWOT analysis to produce alternative PMC1 and using post-analysis to obtain alternative PMC2. Number 2, the selection of business model is done using Minnow decision-making analysis and obtain business model selected as PJB UPHT calibration laboratory business strategies is alternative PMC1 to be implemented in first 2 years and alternative PMC2 to be implemented in the next years. Number 3, further research can be done so that the business model canvas can be applied. Then a strategic action plan is carried out on the 4 main building blocks that are most influential on the implementation of the business model canvas. This is the presentation of this paper. Thank you for your attention.
Okay, Mr. Irfan. Let's move on to the Q&A session. Here we have question for Mr. Mastur. How this solution will affect PJB business in the future? You have 15 minutes to answer the question from live Zoom group chat, and I want to remind the participants to ask the question in the Zoom group chat. Okay, Mr. Irfan, you can answer. I'm so sorry, Mr. Irfan, you still in mute.
Okay, thank you for the question for Mr. Masnur. How this solution will affect PJB business in the future? Okay, right now PJB in the next future will be need fresh money. So the side business like calibration will be provide the PJB for the fresh money, because if we develop this business will be link the need of the customer, that need of calibration industry that still developing, because the AEC, Asian Economic Community, that need of the standardization and the metrology. So the Indonesian product will be can mass product to Asian. So the business of calibrations will will be make PGB can have a business that supports the line of PGB business, because the tool of the need of the industry like the power plant industry is still a lot, like the maintenance unit in UPST that have hundred of tools that need of calibration each year. That's uh, it can reduce the cost of the internal PGB like the UPST as a maintenance unit about more than 400 million each year. And if we develop the business of calibration in the internal PGB, maybe it's a million rupiah can be reduced of the cost of the need of calibration. That's before we must calibrate in the outside of a laboratory. So the impact of the PGB business will be good, because first we will reduce the cost that must be we for before we calibrate to the outside. Now we can calibrate inside ourselves, and we can open the business calibration from the other industry like in the UPST that's location in Gresik, Jawa, East Java. There are other power plant industry that need of calibration. Because most of the laboratory will be in the Jakarta, so the East Java is still have a lot of chance for the calibration business. Maybe that's the effect of the business laboratory for the PGB business. The answer of Mr. Fikri, who is your potential customer, power plant company only or others? Okay. In the value proposition, we have in our value proposition of laboratory calibration, we have the most of the potential for the power plant company, but it's not restricted only the power plant company. We have lots of chance with others company that the laboratory has four main business for laboratory. First is electricity, that we can calibrate tools of electricity like multimeter and current calibrator or current ampere and each. And the other is pressure, temperature, and maybe in the next is dimension. So the laboratory in the first we set for the power plant company, but it's not restricted only, because the others company that have used the tools can be calibrated in hours in the next feature. So the potential customer first is power plant company, of course, but the others industry is also our potential company. Okay, I hope my answer is enough. And the next answer from Mr. Alfian Sultani. From what I see from BMC of the cash calibration business, is there any other channel for marketing the service? Offer this calibration service expand to? Okay, in this current business, we are still in the internal. In the next current model business, we will join with the business solution to expand the business, because our marketing will be in the head office that's in the business solution division. So we will expand maybe in the first is in the PLN group and other power plant company that surround our base in the Gresik East Java. And in the next future, we will join with UPHP, the other maintenance unit in the Jakarta that also have a laboratory calibration laboratory. So we can join and divide the customer between east and west. So we will capture our potential market in Indonesia. We'll divide the laboratory and we can make a teamwork with our tool and join the tools that have the UPHP or ULab have. Okay, next is from Mr. Osas. New business will require knowledge and resource. Did you also consider to research about this? Of course, the new business will require knowledge and resource. So in the next alternative business model canvas, we will also have need of resource like the manpower and other infrastructure like more adding the tools, master calibrators tool and other. So we will develop the business model canvas in the steps. First is we will apply the PMC alternative PMC ones, and for the next 2 years. In the next 2 years, we will add the infrastructure and the other resource from one step to other. So we hope that 2 years we will be applied the PMC2, that's more capability to expand the business and capture more potential customers in the others than PGB group or PLN group. So the process will be in the next 2 years for the adding the resource and other infrastructure, so we can expand the business and capture all of the potential company. Okay, maybe there are other question or maybe question that's not satisfied. So I hope you to question again or maybe make more another question.
Okay, for the participants, if you want to ask another question, please ask in the live Zoom group chat. Oh, okay, Mr. Irfan, there is a question for Mr. Wayan Arianata.
Okay, from Mr. Wayan Arianata, opportunity to reduce maintenance cost for our repetitive cost in PGB for tools calibration and another set. If we want fresh money from other clients, there's a lot of company already provide calibration service. What is our strategic plan to seize market? Okay, our strategic plan is we are know the power plant company that's tools that they have used, because we also use the tools that the other power plant company use. So it's our strategies is the first potential customer is power plant company. So we can provide the calibration menu or calibration method that reach the potential customer in the power plant company. It's the first our strategic. And then in our key resource, we have a tools, master calibration tools in the electricity that have been accredited by CAN. We have a master calibrator that have a high specs. Maybe it's not a lot of the laboratory calibration in the East Java that have it. So it's our opportunity and our key resource that that develop the strategic plan to test the market.
Okay, thank you, Mr. Irfan. Mr. Wayan, is the question okay? Okay, it's good enough. For other participants, is there any question again? If there is not, Mr. Irfan, I want to ask question from, maybe this is a little backwards, but from your initial data, primary data, you mentioned that you do the interview, and you mentioned that you select 5 employees. What is your characteristic to choose that person to become your primary data?
Okay, I choose them because they are the main personnel in the laboratory team. So they are is the core of the laboratory team. So they have the idea and they have the jobs to make the laboratory work. So they are our important important resource for the data.
Okay, thank you, Mr. Irfan. And this is a great idea and an opportunity for our company. What do you think, from your opinion, is the biggest problem to do this research, to implement this research?
Okay, the biggest is of course the resource. Miss Manuela, the resource is our manpower is still have others main duty because we are a maintenance team. So our main duty is overhaul, power plant overhaul. So it's the biggest obstacle from us. But we are in this moment we will apa namanya? We will make some personnel to be laboratory team that not have other duty. So, and the second is the money, of course, yeah, the money for investing calibration tools. We are investing tools with a few years. So it's not only 1 year to developing the laboratory calibration. It's need a few years to make its full operating. That's it, Ms. Emanuela.
Okay, thank you, Mr. Irfan Ardiansyah. If there is no more question, this is the end of the Mr. Irfan session. Thank you, Mr. Irfan Ardiansyah, for your scientific paper with the title PT PJB UPHT Calibration Laboratory Business Strategy with Business Model Canvas Method. Okay,
thank you
next.
for your attention.
Yes, Mr. Irfan Ardiansyah. Okay, next we will proceed to the next scientific paper with the title Development of Reliability-Based Decision-Making for Optimum Operation Maintenance Strategy in Coal-Fired Power Plant, which will be presented by Mr. Muhammad Furqan Aksani from PT PJB. Mr. Furqan, are you ready to spark your silver horizon? Okay. Mr. Furqan?
I can hear your voice. thank you for your chance. For a few minutes, we will present about my paper related to how to manage the OM in coal-fired power plant, so that can give more benefit to the company. Okay, thank you.
Okay, Mr. Furqan, you have 10 minutes to present your paper and 15 minutes to answer the question from live chat. Please begin your presentation.
Okay, hello everyone. I'm Lukman. I'm on behalf of Mr. Furqan and Mr. Yuniarto. I'm here to presentate one of the paper about development and reliability-based decision-making for optimum operation and maintenance strategy in coal-fired power plant. It's from our companies. And this is the outline. The first one is introduction and literature review. The third one is methodology, result, and conclusion. 5 phase. The first one is introduction. The research background. The first one is recently electricity business challenge is how power plant can operate reliable and more efficiently. That's the best power plant as we know for now. The second one is operation maintenance, or OM, costs only about 15% of all life cycle costs, and this figure may fluctuate to around 20%. And there's several options of power plant OM could be optimized. And then this DSS, or decision support system, is a very important tool to select appropriate OM methodology for maximizing our profit companies. The research aim, of course, to create a model of optimize several option OM strategies used in managing coal-fired power plant. Therefore, they can provide maximum benefits, indicates from net present value, or NPV, and reliability or availabilities, because that's how we see from the power plant. It's all about efficient, reliability, and availability. There's two aims. The first one is asset owner. It's to determine appropriate OM methodology will increase return of asset, or ROA, and return of equity, or ROE. Second one is to determine strategies. Therefore, its price remains competitive in the market, so that our companies stay healthy in financial, because they can still survive. And for the OM companies is to assist OM companies run their business remain efficient. This yields maximum profits. The research constraint, the first one is the model test by actual data from a 600 coal-fired power plant in Indonesia, like Python, 9 Python Ubejom in our companies. And second one is to analyze cost structure is related to operation and maintenance phase. The third one is equipment reliability within useful life period. And the fourth is research point of view as asset owner. That's how we see it. And we're going to literature review. There is power generation OM option. This is from Mercer, 2009. It's about evaluation of outsourcing decision of power plant station operation and maintenance service. And then from Kulkarni, Arkwal, Sis and Friends, 2013, is about outsourcing operation, a new trend among IPPs, or independent power producer. This is the previous study, is from the Mercer, 2009. There's 5 options of OM outsourcing available due to its scope of work. And decision-making criteria are life cycle costs, reliability and availability, quality, management, health, safety, environment, performance, overhead, and transaction costs. And weakness is for reliability was the time independent. Decision-making was subjective due to expert competence. From Santamino 2014, the DSS, or Decision Support System, is about coal supply for power plant using system dynamics. That's about a 800 megawatt period, considering related exogenous factors, and objective function is to maximize the NPV, NCF, payback period, and IRR. This is from APRI's Power Plant Technical Economical Map. It's about payback period, cost analysis only for OM phase, for sure. This is from APRI's Power Plant Technical Economical Map. Next one is methodology, cost analysis only for This OM is the method, for sure. Deciding about system dynamics from model, developing from a power plant report or corporate document and etc. until we finding analysis model, of course, simulation, running simulation, verification, the results, and we're analyzing that until conclusion. This is the CLD or causal loop diagrams. This is about how our power plant produce energy from a very far away, like in every certain conditions. There is NPVs right here. There's net cash flow. It's maintenance project budget. There's thermal efficiency. Everything is connected from the finance, from the engineering, from how you efficiency of the power plant, from everything. It's connected from the machine, of course, and from the fuel to the price. And now we're talking about reliability and availability calculation. We're using PenSim. We got our data from our companies using Navitas, using a lot of resource of data, so that we found a constanta, and then we're using the failure rate, we're using probability density function, and of course for the availability is from mean time to failure equation based until overall model testing. We're using PenSim. And then this is the structure model development. There's two, reliability and availability model. We're using PenSim. Operation costs. And then maintenance cost model development, cash flow model, reliability and availability model. We're using PenSim. Operation costs. We're seeing the result from there. Cost model development, cash flow. This is the model verification from logical test, structure test, unit consistency. We're seeing the result from there. Sensitivity analysis. This is we build the equation from and then running the simulation after the result was taken. We keep doing some sensitivity analysis just to make sure if that we have a correct loop of equation. We're just making sure of that. There's reinforced feedback loop, and there's balancing feedback loop. This is about the finance and efficiency of the power plant. I mean, like if you give a certain equation in the energy that you use, there's an equation, and there will be finance, like how much money you'll make or how much energy you will provide with the equation. This is the sensitivity analysis. There's NPV power plant, and then capacity factor, coal price, and SE duration. This third sensitivity is to make sure that the equation that you have been built is very good. And then we're seeing from the graphics right here, the year from the 2018 and 2027, there will be a gap between those graphics, so that and any equation that you give, any input, it will makes this equation make the result is keep changing, and that will makes our stakeholder give a very good decision about coal price, capacity factor, and SA duration. The parameter is OM contractor compense or series inspection, dispatch capacity factor, or coal price. We all know about this. This 3 point is very, very vital in our power plant companies. This is the model validation. You showing about mean absolute percentage error, just to make sure that our model is very valid and ready to use for the equation until making decision, of course. We're getting to conclusion. First, this research provides the DSS or decision support system to assist the power generation business to win the competition for sure. For power plant owners, this tool is useful for deciding appropriate OM strategies that result maximum availability and profit. For OM service companies, it's very useful to determine the correct strategy to provide competitive prices without neglecting the quality. So you already know if you make a certain decision, what's the result or the outcome will be. That's really helpful for the board of directors. The second one is variables are the most important sensitive to NPV so that they can take some necessary action before business risk occurred. It known that coal price is the most sensitive variable, is equal about 62%, as we're seeing in that here. The external factor is very, there will be causing a very deviation output in the outcome of this graphical. So it's very sensitive, of course, from that third point of equation. That's about our presentation. Thank you for listening and see you soon. Thank you.
Okay, I want to remind the participants, if there is any question, you can text or chat in our Zoom group chat. We will move to our Q&A session. Okay, Mr. Furqan, would you mind to explain us about our equation for reliability and availability?
Okay, thank you, Ms. Yama. I will tell about my study. Some operation and maintenance is some critical factor in managing a power plant. That some factors are well finite and some another is probably look like from reliability. Reliability is how probability some equipment or some asset is still reliable that can give more beneficial to the company. It's probable. So from one, of course, from 1 to from 0 to 1, it's probability that equipment can function well function. So the reliability I have model, so we can predict how the power plant can give beneficial for the long term period. In my study, I modeled for 10 years, so it's like for the PPA for project power purchase agreement for that, and to cycle of a long-term period. So we can estimate how many life cycle costs that we need to give a better option for the OM. So there are three model in suggested from Evelyn. One is we for as asset owner, asset manager, or asset operator. So we can decide which one the best that give the best NPV. Okay, thank you.
Okay, Mr. Furqan. For participants, you are allowed to ask the question. Mr. Furqan, this is from Mr. Fikri. Where is your take place?
Okay, thank you, Mr. Fikri. I think my study is about a model. So how model is basically can be applied to all of the power plant that is in the similar constraint in my studies, constraint from coal-fired power plant, and then for to making sure that my model is precision, I compare to the real data. The real data we take in our 600 megawatt power plant in Python, in the Python unit 9. But basically, after the model is verified, the real case in the field, we can enroll the model to the other case simulation. Is it for all PGP power plant? Oh, I think it's all power plant can apply my model. So in our model is we model we calculate life cycle costs from the acquisition, operation, and maintenance, and also in the disposal. But we constrain the study only in OM cost. And then we also how many income from the business due to the national electricity commercial by PLN. So we can predict the net present value and from the 10 years. How if we want to benchmark to PJB about this, maybe you can call us to more discussion about this concept. Thank you, Mr. Fikri.
Okay, Mr. Fokar, from your reliability and availability equation, you mentioned that you use variable parameter. What is the reason for your team to use that parameter?
Okay, actually, variable is one of data distribution. Reliability usually distribute in several model. One of them is variable, or maybe exponential or log normal. So from the real data in the field, we simulate what's the better when the better on the precision model. And from my study, the variable is almost real. In the real is go to the variable model. We tested by Minitab software to identification. Actually, it's many software to identify the data distribution. Okay, I may see from Mr. Marco any consideration regarding the implementation to all business process in power plant. My model is developed based on every model. Every model provide some technical and cost model. So like how many coal consumes in the power plant, and we know heat rate, and we know the heating value. It can be model. So I think it's suitable for and adaptable to the all of power plant. So like maintenance method, we know there are tactical and non-tactical maintenance, corrective maintenance have been regarded in my model. So I think Mr. Eko Arianto's question is same with Ms. Emma's question, where you decide using variable distribution. We not decide, but the decision that we using variable distribution is supported by Minitab. So the best model is using variable, but we practice to Webul, 2 parameter and 3 parameter as according to the real data.
Okay, thank you, Mr. Furqan. If there is any question, okay, the participants can give the question in the Zoom group chat. Maybe from Mr. Furqan, is there anything else that you want to tell us about this research? Maybe about the problem or the biggest problem in doing this research and the biggest problem in doing this implementation to our company?
Okay, thank you, Ms. Emma. I think the big problem is because my model is related to the overall business process in the power plant. So it's related to huge data, and of course, to modeling we need more data and more information, and also maybe expert judgment. And then how to convert from the real case in the field, converted into mathematics and FENSIM language. I use FENSIM as one of the system dynamic modeler, like FENSIM, Stella, and so on. It's need logical, high logical. It's question from Mr. Agus Adrian. With code switching can be operating and maintenance costs be optimum. I think it's about the call switching. It's can related to my model. Using call switching from hiring or metering to lowering call, we can entry new data about HHV hitting value from maybe 4,500 become 4,100. In my model, we use lowering call because it's a Chinese power plant, and use lowering call 4,100 kilocalorie per kilograms. Okay, so it's chat from Mr. Lukman. I think it's not some question. From Mr. Harsono, what if this reliability is applied to other type of power plant? Okay, the reliability is maybe some it is specific for every power plant, and then how can we apply the model to the other power plant? I think it's need further study to identify the reliability coefficient. In my paper about the alpha, beta, or maybe gamma, we can identify from this power plant, and then after we model, we got the reliability coefficient, we can input on the FENSIM, and the model is can be used in the other power plant. Thank you, Mr. Arsono.
Okay. Is there any question from our participants? You can ask in our Zoom group chat. We still have about 4 minutes.
Maybe before we writing the question,
Mr. Furqan? I think Mr. Furqan has a problem with the signal, with the signal over there. Maybe we should wait for 2 minutes for Mr. Furqan to join us again. Mr. Furqan?
Okay,
Okay.
I'm here.
Okay, Mr. Furqan, you can continue. What do you want to inform us?
I'm sorry, it's disconnected.
Yeah.
Okay, I think our model is that our company is facing a latest the big question that the electricity or power generation is very nice business. Both of we as asset owner, asset manager, asset operator. So this model can help give a guidance from the management to yield the more benefit from the company, for the company. Thank you.
Okay, thank you, Mr. Furqan. We are really sorry to inform the participants that the Q&A session is over. And thank you, Mr. Danam, Mr. Furqan, for your scientific paper with the title, The Development of Reliability-Based Decision Making for Optimum Operation Maintenance Strategy in Coal-Fired Power Plant.
Okay, thank you, Ms. Emma, and all of participants. Thank you.
Ladies and gentlemen, time flies so fast during this amazing presentation. Let's take a break for a moment and we will see you again at 1:30 p.m. Okay, see you at 1:30 p.m. Thank you.
Dalam mengatasi perubahan iklim, negara-negara di dunia telah berkomitmen mengurangi emisi gas rumah kaca atau GRK. Di Indonesia, upaya ini tercermin melalui target emisi hingga 29% pada tahun 2030 dan bauran energi nasional untuk energi baru terbarukan mencapai 23% pada tahun 2025. Di bidang kelistrikan, komitmen Indonesia dibuktikan melalui teknologi co-firing. Co-firing merupakan proses penambahan biomasa sebagai bahan bakar pengganti parsial ke dalam boiler batu bara. PT Pembangkitan Jawa Bali sebagai anak perusahaan PT PLN Persero mendukung salah satu aspirasi utama dalam transformasi PLN yaitu green, menjadi pionir dalam mengembangkan dan menggunakan teknologi co-firing di Indonesia. Melalui metode direct co-firing, biomasa dicampur menggunakan peralatan penggiling atau grinding dan pengumpan atau feeder. Kemudian dicampur dengan batu bara ke dalam boiler yang sama maupun boiler terpisah untuk dibakar. Keunggulan dari inovasi co-firing adalah tidak adanya investasi biaya peralatan khusus atau zero investment equipment. Metode ini merupakan cara pembakaran bersama yang paling banyak diadopsi oleh boiler jenis pulverized coal.
PT Pembangkitan Jawa Bali telah berhasil melakukan pengujian co-firing biomasa di 10 PLTU dengan jenis boiler yang berbeda-beda, baik di Jawa maupun luar Jawa, mulai dari PLTU skala kecil di Belitung sampai dengan PLTU skala besar 660 MW di PLTU Paiton 9 dan telah go live komersial di PLTU Paiton Unit 1 serta Unit 2.
Dari hasil pengujian didapatkan segi operasi hingga 5% co-firing tidak diperlukan modifikasi pada peralatan pembangkit, serta parameter operasi terpantau aman. Penurunan temperatur gas buang tidak terjadi aglomerasi. Segi lingkungan, memperbaiki kualitas emisi dan masuk dalam batas baku mutu emisi Kementerian Lingkungan Hidup dan Kehutanan. Indonesia memiliki jutaan potensi yang dapat dijadikan sumber energi ramah lingkungan. Co-firing sebagai salah satu pemanfaatan potensi menawarkan berbagai aspek positif di industri kelistrikan. Co-firing adalah solusi tepat dalam menjaga bumi dan tentu turut menjamin kelangsungan hidup yang nyaman untuk kita, anak cucu, bahkan juga cicit kita.
Saat ini, kita tengah memasuki era baru, Industri 4.0. Industri 4.0 merupakan era transformasi yang memadukan pemanfaatan teknologi dengan berbagai industri, memunculkan berbagai inovasi penting seperti IoT, cloud storage, artificial